This is Unit 2 forces. I chose forces because I've always had a hard time setting up the equation for each question. I wouldn't be able to put the right mu in the right spot. Normal force would be wrong. Something would always be wrong, and I couldn't figure out why. So I figured that restarting forces, refreshing the mind, getting a better grasp of it will help in the long run because UCM uses forces, energy does, kinetomatics, momentum, all of those courses use forces in its calculations. So hopefully by redoing this, it'll better my understanding of forces. Specific concept that I will cover. Inclines is really big for me. I've always had trouble with inclines because I couldn't set up the right equation along the x and y plane. So hopefully this will be a refresher. So all of them are going to be inclines with friction, going to be at rest, and the pulley system. Both of them are going to be a transfer from mu static to mu kinetic. So just to go over, forces are always in newtons, which is mass times by acceleration, or kilograms meters per square second. Force of weight is mass times by gravitational acceleration, which is gravitational acceleration is 10. In this case, it's going to be force is equal to mg, force due to weight. The normal force is the opposite force due to weight. This force always acts perpendicular to the surface on which it sits. So even if it's inclined, it's still perpendicular to that incline. Because of that, the normal force has no equation. You always have to calculate out that equation. Friction. Friction is equal to mu times normal force. And mu has two types of coefficients because it is the coefficient of friction. It has static friction, which is friction of no movement, and kinetic friction, which is friction of movement. Static friction will always be bigger than kinetic friction because it's always easier to keep something moving than it is to start it up from rest. It takes more force to get it to go. That's why. So things I like to remember. You must always consider the forces along x and y. For example, inclines, there are different components for x and y, and they always change. And it's helpful to use the Pythagorean theorem right here to find the final component using your x and y. A squared plus b squared equals c squared. And then you can use trigonometry to find the angle or to find the side length of the triangle or incline that you're trying to use. Very helpful. So here we go. Problem 1. A box at rest sits on an inclined angle at 40 degrees. Static friction between the 30 kilogram box and the surface is 0.9. What maximum force can be applied to keep the box at rest? When the box is tapped, what is the acceleration of mu kinetic is equal to 0.4? Here's a brief diagram of what I wrote. First solution, our applied force. So we wrote our free body diagram. Since you're pushing it up, our applied force is going to be obviously positive. So it's going to be pointing in this direction because it's positive. So therefore, we're going to have friction acting against us right here. Friction is acting against us. And we're going to have weight acting against us too. It's pulling back, which is mg sine of theta. I drew some triangles here using trigonometry and the Pythagorean theorem to determine these side lengths. So we get mg sine of theta as the one that's going back because this is at the angle that the box is. So when we go to set it up, since these are both negative, it's going to be your applied force minus your force of friction minus by your force of weight, which is mg sine of theta. It's all going to be equal to 0 because it's not moving. And because force of friction is equal to mu static times by the normal force, and the normal force is equal to mg cosine of theta, using this component right here, because these cancel each other out, we put this in here, and we get this beautiful equation. We simplify it, and we get your applied force equal to that, which is 399.67 newtons or 400 newtons. So that's the max force that you can push against the box to keep it from moving. B is the transfer from mu static to mu kinetic. What's the acceleration? So we're going to use the same equation we did here, put it right here, but in this case, we're going to use mu kinetic because we are moving. And it's going to equal ma, your mass times your acceleration, because it is moving. You got to compensate for that. So we do a little simplifying. We apply our numbers in here, and then we get 114.9 meters per square second. That's a lot because it's a big transfer from frictionless to light frictionless, so it's going to be a big pop. This can be interdisciplinary because you can find how far that object will project, how far it will go, the distance, how high it will go, how much energy it goes through, all that fun stuff. Problem 2. M is equal to 10 kilograms. The box rests on an incline connected to a pulley system of negligible mass and friction with a hanging mass. The incline angle is at 50 degrees, and mu static is equal to 0.9. what is the maximum weight m the hanging mass can have to keep the system at rest? When the system is barely nudged, it accelerates at 2.5 meters per square second. What is mu kinetic? Again, transfer over. So right here, we're going to try to find big M. So we look at this, our tension force is really big here, and we go back to the beginning, one-dimension forces, and we use this equation right here. Mg minus your force of tension is equal to Ma. That's if it's moving down, because of this, your Mg is going to be bigger than the force of tension you can handle. That's why it's moving down. But in this case, it's zero because it's not moving whatsoever. It's at rest. We want to find M. So we simplify that. Force of tension is just going to be equal to big Mg, and then we're going to find that mass. And then back to our similar equation, our force of tension is kind of like our applied force. That's what's keeping everything together. And your force of friction and your force due to weight is acting as negative values. So force of tension minus your force of friction is minus mg sine of theta is equal to zero. Zero because it's at rest. And then we apply your friction with your normal force mg cosine of theta using this component here. And then we throw all that in here to get this beautiful equation. G cancels out, which is nice. And then we get M. Plug in our values, and we get 13.45 kilograms as our big weight, the max weight that can be. So now B, what is mu kinetic? Well, that's be fun right here. Well, since this right here is now moving, because it's kinetic, now it's moving, mg minus force of tension is going to equal to big Ma. So right here, it simplifies to m times by the quantity g plus a. So that will go back into our original equation that we stole from here, right there. And then that'll be force of tension, which is that. Force of friction is going to be mu kinetic. That's the only difference. And then it's going to equal the quantity big M plus little m times by a, because they're both moving. And so we get this beautiful equation here. And then I plug in the values, simplify a little bit, and then we isolate mu kinetic, and our mu kinetic is 0.512. It's a big change, but it's not as big as 0.4 because it's a lot lesser mass. So that's what we have right there. That's our transfer right here using our x and y components. This really helped me. So what did I learn? I learned to take my time, write out the free body diagram, show where all the forces are going, determine which ones are negative and which ones are positive. That helps you set up stuff. Write those little triangles things to determine the normal force and the force due to weight, where those are transferred. Write all that down. Find the forces which are acting negatively. I said that. Write down the triangles. I said that. You got to write it down. You got to find the right component. And don't be afraid to look back at your references. Ask your friends, ask your teacher, look in your notes, refresh yourself with that kind of stuff. It's very helpful to determine everything. And of course, you want to write detailed notes. You want to write the entire question, and you want to write your thought process, so that way you can go back and say, oh, this is what I did, and this is how I got the correct answer. So all of that, I got a better understanding of inclines and forces. Hopefully, this will transfer over into UCM, and I will increase my agility in these areas. And I thank you, Mr. Hunt, for giving me this opportunity to relearn and reteach myself forces and give me a chance to redeem myself. I really appreciate it, and I thank you very much. And it's been a pleasure to be in your class, and you take care. Thank you very much.